All right, this video is going to talk about a few different trig identities. Again, a trig identity or trigonometric identity is just an equation that's always true. So things like the cosecant, again, is the same thing as 1 over the sine, right, of a theta. Well, up top here, we've got what we call the quotient identities, and on the right, the Pythagorean identities. A quick proof, again, we don't have to do a lot with it, is if we think about a triangle, right, I'm just going to sort of define any old triangle. It's a right triangle. And I'm going to call the different side lengths, so A, B, and C. And let's just think of theta. We'll just make it this angle down here. It's kind of arbitrary. It doesn't really matter that much. Well, again, if we think about that tangent up top here, tangent equal to sine over the cosine, definitely a ratio or an identity we want to get to know. Well, think about that. We're saying that the tangent of theta, so that would be A over B for us, right, would be equal to the sine, so A over C, divided by the cosine, B over C. And we simply know, using some basic fractions, again, if you take the bottom and multiply by the reciprocal, we'll cancel those C's, and basically A over B, right, the tangent equals A over B. So again, the sine over cosine on the right ended up equal to the tangent on the left. You can do the cotangent sort of that same way. Pythagorean identities sort of work that same direction. Again, if we did the sine squared, that's going to be A over C squared plus B over C squared is equal to 1. Well, is that really a true statement? Well, what I would probably do, and notice I put the squareds in on that second one, so let's go ahead and do that on the first one as well. What if we just multiply all parts by c squared, right? What if I just go ahead, we'll take this whole side times c squared and this side times c squared. Well, in that first fraction, that leaves us with a squared. In the second fraction, again, the denominator will cancel, leaves us with b squared. And on the right, we've got c squared. And I don't think anybody's going to argue with the Pythagorean theorem, right? So again, the idea is these identities are true at all times. For any angle theta, these will always be the case. Now, where can we take advantage of that? Well, one place is quickly solving if we know some previous information. So given that the cosine of theta is 0.8 and the tangent of theta is 0.75, how could we quickly find the sine? Well, one option would be we draw a triangle out, right, and label the parts and try to make these things fit. But another one would be to say, hey, if I'm looking for the sine, if I know the cosine and the tangent, that sounds a lot like my tangent quotient identity here, right? Tangent of theta equals sine over cosine. So if the tangent of theta, right, take advantage of this one here, the tangent of theta is 0.75. The sine of theta is what we're looking for, right? Again, we're not looking for theta, but we're looking for the sine of theta. And the cosine of theta in the denominator would have been 0.8. Well, if we're dividing by 0.8, let's go ahead and multiply it over to the other side, leaving us with the sine of theta. And very simply then, the sine of theta will be equal to. Now, I've got to actually do that multiplication, so I'm going to go ahead and pop onto the calculator here. 0.75 times 0.8 would be equal to 0.6. So again, the sine of theta would be 0.6 for our problem. Same thing down at the bottom. Now notice this time they only gave us one identity, right? They only gave us our one value here. The secant of theta is equal to 2, but we want to find the tangent of theta. Well, the problem is we don't really have that happening up in the quotient here, right? We need at least 2 to find a third one. However, down at the bottom, notice that Pythagorean identity, tangents and secants relate very well via that one. So let's grab that middle Pythagorean identity here. And we'll just say 1 plus, again, the tangent of theta. We don't know the value of that. Now realize tangent squared essentially means we're taking that whole trig function squared. So if you'd rather write it that way, you can. We're not squaring the angle, we're squaring the function. Which means in the same way, secant squared is really 2 squared right now. I'm going to take the secant of theta and I'm going to square the function, right? I'm going to square the whole thing. So now this is tangent squared of theta equal to, again, would have been 4 on the right. Let's subtract that 1, makes it 3. The next thing I'm going to get rid of again is that square. So tangent of theta equals the square root of 3. And technically, because we don't know a lot about this, we should say plus or minus. Again, if we're thinking about actual side lengths or things like that, we really shouldn't come out negative. But again, to be technical, tangents can be negative. We'll talk about that in a future lesson. So again, I would say there's our answer. Now, keep an eye on the directions, because if ever they do say tangent of theta or all of our trig ratios need to be positive or anything like that, again, we wouldn't have to worry about that negative in the plus or minus on the bottom there. Hopefully that helps you dealing with those identities. A couple of other identities that we know, or a whole bunch of them here, are what are called the co-function identities. Again, the sine of 90 minus theta is the same thing as its co-function, the cosine at just theta, right? And we could look at this a little bit as well. It kind of makes sense. If you remember, the cosine at 30 degrees, which is technically root 3 over 2, would be the same as sine at 60 degrees. Again, comes out as a root 3 over 2. So the idea is to say that, hey, the cosine at 30 would be the same thing as its co-function, the sine at 90 minus 30, or basically the sine at 60 degrees. These two co-functions, right, for complementary angles, right, 30 and 60 add up to 90, so those co-functions will have the same value. Now that works beautifully for both the cosine and the sine in both directions there. It also works for the secant and the cosecant, also works for the tangent and the cotangent. So again, if ever you have two angles that add up to 90 degrees, right, they're complementary, basically their co-functions will have the same value. So down at the bottom, we can take advantage of that. Notice that we want to find the tangent at 90 minus beta. Well, that should be equivalent to the cotangent of beta. Well, if the tangent of beta is 5, we can label our triangle over here. Let's just say beta is this angle down here. Again, it's pretty arbitrary. It's just a random triangle. And tangent, again, its ratio, remember that's always a fraction, is equal to the opposite over the adjacent. Well, in that case, the cotangent would just be adjacent over opposite, or basically 1/5. And if the cotangent of beta is 1/5, then the tangent of 90 minus beta is also 1/5. Again, study those identities, take advantage of those identities, and if you have any questions about identities, such as the co-function identities, or the quotient or Pythagorean identities, make sure you talk to your teacher. Otherwise, have a great day.